Okay, so this is lesson 1.4.1 for PLTW for engineering, and I already did this, but I recorded it horizontal, and the video is all messed up. So here it goes again, tape 2. So our group members was me, Matthew Jablonski, Matthew Bonet, and Lucas, and our first brainstorm idea was to use one motor. It would be lightweight. The solar panels are our primary source of energy, and the hydrogen cells would be used as a secondary, and we'd use a gear train for increased power. That would later be changed, but for now, let's move on to the design challenge description. So our group will need to move a car made up of materials used in the classroom. They can be powered by hydrogen fuel cells or solar panels. And so the final goal was to go outside and race them, and the goal would be 15 feet, and the secondary goal would go as fast as possible. So it was us and 3 other groups, I believe, and we were kind of racing against each other, so that was kind of fun. So part 2, vehicle modification plan. Part A was the brainstorm ideas, and these are the drawings. So 1A and 3A are kind of similar. They both use solar panels. They both have, I didn't draw a motor on that, but that one has a motor right there. I'll fix that up. That one has a motor. They all 3 have motors. These 2 have solar panels, and this one use fuel cells. Now we would later take this and kind of revise it a little bit, shown there. I'll go over that in a little bit. That's our final one. But these were our 3 brainstorming ideas. Moving on to the design matrix. So car 1A, so I'll give you a better look. That's that car there, and that's the thing. 2A is this one here, 4 wheels. We got 2 fuel cells, motors powering the gears, and 3A, you got 3 wheels. So it was kind of like an in-between thing of these 2. We were at first going to use solar panels for our thing, but we took those off the day before. And design matrix, so here it is. So 1A, well, let's first go over the question. So can it finish? What was its speed, like how fast can it go? And its reliability. So car 1A and car 3 are actually kind of similar. So can it finish? Well, it'd have to be a sunny day. And in Jack's group, they were able to finish first place. I believe they got under 20 seconds, like 19.7 or something like that. And, they won, but they were just sitting there for 45 minutes, and it wasn't very reliable. So car 1A and car 3 are not reliable. However, they're very fast. So in the end, yes, they did win, but it was unreliable. 2A, the fuel cells are very reliable, and that's why we would use them. The speed, so obviously the heavier it is, the less speed you'd have. So 1A would be lightweight. The solar panels would provide great speed, however, it was not reliable, so we did not want to take the risk. Kind of the same thing in 3A, however, it was heavier, so it didn't really make a lot of whole sense to really use 3A at all, so we automatically crossed that out. So now we have like 1A and 2A, and we're like, well, should we go with something fast but like make it very risky, or should we go safe and just use fuel cells? So we did go up with 2A, but in the end that did not work out, so that'd be a question for later. You'll see there. So final sketch was, and this is the final sketch annotated. Unfortunately, I don't have any pictures or videos. I kind of wish I did that, or someone else in my group, but nope, we didn't, so this is the best we got. So we got 1 small wheel in the front, 2 large wheels in the back, and we had a motor connecting to the gears, I believe, or maybe it was this, no, it was the steel thing there, and this kind of like it powered the back wheels, and the front wheel was for support in order to make it kind of as light as possible, because it was a little heavy, not too heavy, but a little bit. And we used 2 hydrogen fuel cells because 1 wasn't enough, so we had to use 2. We don't really have a great picture of the circuit, but we had one and we made it work. So here's the explanation. We used 3 wheels instead of 4, so the car was lighter. So 4 was a bit heavy, and it would still have the same amount of stability. And we went with hydrogen fuel cells because we did not want to take any risk of having the car not start. It was very close to one of the groups. They got lucky at the end. And the hydrogen cells were powering the motor that turns the gears, which makes the wheels turn. So down to the vehicle prototype documentation. This isn't the best drawing at all in any means, but it looks something like this. Like there were some wires crossing into the middle section, on the right side to the middle section there. So let's just move past that. So evaluating the solution from testing. So I want to talk about a quick 30-second story right now. So basically we were gonna finish the car, but one of our group members saw us finished, and he basically picked up the car, and the hydrogen cells dumped everywhere, and that kind of ruined it. But luckily the day before we proved we could finish it, and we proved it in other places. So yes, it could finish, but we did not have a speed for it, so I can't provide any speed calculations or anything like that. So yes, we got a 0 for speed, I guess. And we went for another hydrogen cells. We used another hydrogen cell, and the same thing happened. It got dumped over. So technically you can count that as an unreliability, dumping the fuel cells. That was just unfortunate, but that was all explained there. So our team would have used some solar power energy, because when the other groups used it, the car went faster. We made the mistake of not taking the risk we should have, and I think that actually hurt us in the end. I didn't pull up the question before this, I guess I said, so I'm just going to read the statement and then provide the question. So I said for part C, whatever this question is, yes, our car was able to run just on fuel cells, and this would not be the best children's toy, however, because it was kind of an eyesore to look at, and it does not require batteries. Okay, so this is answering the question too, like, did this fulfill the design statement, which was what you needed to do, which was to basically build a toy car for children without the use of batteries, because batteries are kind of a pain. So yes, we did do that. I would not recommend it though, any means, for a child. I would just use batteries. And part D, we said, okay, this is like what we learned, I think. We learned that solar panels are great for speed of motor, but are certainly unreliable. That was proven on the test day. And the challenge we crossed was on the day of, we went over this on the day of testing. We spilled our fuel cells everywhere, and that kind of ruined it. And the purpose of the design problem was to find a good way to build a children's toy without the use of using batteries. I think everyone did that. No one used batteries. Everyone used fuel cells or solar panels. And so this has been lesson 1.4.1. Thank you for watching.